I guess we'll go ahead and get started with the call. Today is June 24th, and it's about 12 o'clock Pacific time here in Spokane, Washington at the shop. Here with Eric Dollard, who's been here for several days, almost a week. We're working on some of the presentations for the 2023 Energy Science and Technology Conference. There's only 11 tickets remaining for the in-person attendees. You can go to emediapress.com. When you scroll down, the first big thing you see is for the conference, and you can click on that. You can scroll down to see all the events listed there. There'll be about 17, 18 presenters, about 20 presentations or so. I think it's the most packed schedule we've ever had. So it'll be a 5-day event, July 5th through the 9th, which is a Wednesday through a Sunday. And so there's 11 in-person tickets remaining, and there's plenty of streaming tickets at a reduced price, lot less than the in-person attendee tickets. Eric Dollard's heads up the EPD Laboratories, Inc., which is a 501c3 nonprofit organization. Hold on a second, let me hit my video here. And it's a nonprofit registered down in Nevada that supports Eric's research in the electrical sciences. And a lot of what you're going to see on the call today and different updates and stuff is going to be relevant to all that kind of work. Eric is currently working on a, hold on a second. So he'll working on a music presentation applying the 4-phase analysis method to some of Bach's music, and a 4-phase presentation on 4-phase electricity, which is Tesla's
polyphase.
And there's not a lot of information about it.
No one really knows much about it. No one's ever fully analyzed it.
Okay.
Not that it's available anyway that I know about.
So that'll, definitely be the definitive presentation on that. Griffin's on the call. Adrian Haka says they all are going to be presenting as well. Adrian has a couple presentations. Haka says has one. Griffin has a presentation. You can look at the details and all that on emediapress.com. Again, just scroll down and click on the conference link, and you'll see the full schedule. Anything you want to start off with, or?
No, not until I get warmed up on something.
Okay, so maybe we can kind of go into the Justin's
yeah, that's what I want to do.
Picture show on the recent episode down in Tonopah. So Adrian and Eric were up here in Spokane for quite a while. We got a lot of stuff done. Then as soon as Eric went back down to Tonopah, there was another big episode down there. I think Griffin and Haka says and Justin and I think Steve Young and Steve McGreevy. Yeah. Well, we're all there.
We got a lot of stuff done this time around.
And a lot of it is related to the telluric Earth transmission experiments and different organization and the Radio Shack and stuff. So okay, Adrian or Hawk says, Griffin, any of you want
to? I was really just going to say, really, I've just been kind of reviewing presentations and backing up equipment. I have got two full suitcases of equipment, which is now coming with me to the US. What was already there, I bought last year, and Aaron's received a few parcels for me as well. So we should be pretty well set up. That equipment is running fine. That's the GU5B generator that I'm bringing with me, and the tuning gear as well. That'll be running for the golden ratio discharge work. Those are the main things that I've been focusing on. So really, I'll keep any further updates until we get to the conference. Thanks, Aaron. That's everything from me. Griffin, what about you?
Yeah, so I've been working on quite a few things as well, finalizing project details. I won't really get into the latest research which I've been able to uncover with some of the tubes I've constructed, but if I'll share my screen, I could show some rather interesting products that I will be bringing to the conference with me. Can you see my screen all right?
And don't tell them what the price is. They can
Yes,
find it at the
exactly.
conference.
So the essentially, over the course of the last half year, I've been perfecting the shadowgraph tubes and other radiant matter tubes. And at this juncture in time, I have been able to perfect a very compact unit, of which you're seeing multiple models of. And I will be bringing these with me to the conference for any fellow experimenter who wishes to toy with them. And they are of simple construction. They are all standardized with 2 bases and what have you, which makes it quite easy for the experimenter to use. And here, if I could go to the next picture. This is a close-up of the tube. It is the 1A21 desmitron. Desmi in Greek essentially means beam or beaming, and the tron will just follow suit. So this is essentially the perfected radiating beam tube that I've been able to construct. Legally, it has patent pending status, as it is a rather unique tube. And per the discoveries which I've made recently within the past month, it is a rather astounding tube. So simplistic in design, yet its possibilities are seemingly endless. And of course, this is one of the tubes or the tube types I'll be bringing for retail at the conference and for demonstration, but also the perfection of Tesla's single wire lamp, which you're showing here being illuminated to half power. It radiates a very intense light, seemingly from a tiny little filament, which you're seeing incandesce before the screen. And of course, like with all the other Tesla-related lamps, there is a very intensive research effort just to perfecting a model that could easily be in the hands of the experimenter. Lots and lots of man hours, research, critical thinking goes into this design to make it what it is. So I would say that the level of incandescence and the level of light output that such a tube such as this would radiate is around similar to that of a 20 to 30 watt incandescent lamp. But of course, that could be raised even higher with adequate potential. And culminating with the rest of the products, this does not include, and it is not limited to just these 2 bulb designs, but as well as the standardized vacuum tube socket, which I've been able to construct and further perfect, that's adaptable to these type of tubes, but also other tubes that I'll be constructing and have for retail in the future. Now, I have some other vacuum lamps that do not possess 2 bases, but the experimenter will find quite interesting and, of course, be applicable to even basic apparatuses. So that is what's happening thus far. So if so, I'll hand it over to Hakasus.
Howdy. So I've been working on my own presentations and such. Thankfully, work has lightened up a little bit, and I had some time to work on what is essentially a pair of rotary electrostatic condensers. Those were the Chris Carson, or also known as the Trump motor. It's a lot of work in terms of engineering and practicality. The main issue is to get any realistic amount of power with these types of systems, you have to put the entire thing inside a vacuum and get to a certain degree where it gets on the other end of the knee. So the vacuum actually acts as the best insulator and allows you to reach much higher than normal. And as you can see, there's a lot of engineering, a lot of detail, everything having to be vacuum sealed, having to machine, design, fabricate the motor adapters, have to set up the motor, make the high voltage takeoff, the motor drivers, everything like that. But it is finally coming together, and they do spin in a vacuum and they do basically function. So I have a few more little things, but at least it looks like we're going to have something to present. The only other thing is I don't want to push them too hard and have it implode, because then it wouldn't be very fun, would it? So Yeah, fun conference season. One of the other ones I was talking with Jeremiah, and if things work out, we may be able to adapt one of these motors with Jeremiah's Tesla turbine and possibly demonstrate a end-to-end rotary electrostatic converter powered by Tesla turbine or a Tesla motor. So that'll be kind of cool. Anyway, that's about all I got. Hopefully the downloads and transfers and all that went okay. Anything up? Any luck, Aaron?
Let's see, I don't see a response from Justin and Signal as far as a zip file yet. But I got a question about the Trump deal because that's something that me and Jeremiah wanted to do anyway. We just didn't have time. He's barely got time to just get the turbine going. But on your unit right there next to the capacitor plates, you had a enclosure over one end. Is that sealing up the motor that's going to be driving it, or?
Yeah, there's actually two ways of doing this. I was originally trying to use a rotary vacuum seal, but the friction turned out to be higher than I hoped. So yeah, the entire motor drive assembly ends up having to get cased inside a vacuum along with the other. This is actually the smaller version of the two motors that I'll be working with. You know, if you have one and it blows up, then you have no toys to play with.
And what RPM is that motor going to spin that at?
These are not going to be very high RPM, under 10,000, probably more like 5 to 7, depending on how vibration kicks up. But thanks to the vacuum, we'll actually be able to exceed. We should be able to greatly exceed what we had on the Carson motor. Back of envelope math puts us at least 50 watts, probably a couple hundred, depending on how deep the vacuum gets without imploding. Could get all the way up to watts with a larger motor, but it's all up in the air at the moment. We don't want to push it too hard yet.
Now on the opposite end of the shaft, where nothing is connected to it, is there a possibility to put a diametrically magnetized neodymium magnet on there with an enclosure as well?
I already talked with Jeremiah. I have the specs for the diametric magnets, and I'm working on the end plate adapters to, instead of have the motor, to have it adapt to his drive system. So I should have all the pieces ready to go, but we'll see how well it actually works when it's game time.
Okay. And is there a possibility for us to use the audio modulator bay to potentially get that up to speed, turn off the motor and see if it'll keep going, or?
That's kind of, it's got a network that's got to go between the modulator and the motor.
Okay.
There has to be a pi/2 network to turn because the modulator is constant potential and the motor is constant current. And the motor is going to want, probably like 100 kilovolts. So we have to have a quarter wave network that turns amps into volts. So
okay.
So basically, it's basically just 2 coils and 2 capacitors. It's kind of like those analog computers, but because it only works on one frequency, you just need one element. You don't need a concatenation of them. You just need one.
That'll be an after the conference project to
do
all that other
yeah,
stuff.
these are both going to be around the 50 to 100 kilovolt range, hopefully, depending on the vacuum.
Okay.
So I guess I can go on what we did down there because Justin's having problems with the pictures. So I'll just kind of timeline it. Let's see. So the first thing we did is Justin has successfully glommed the pole from his fixed location, and which saved us the effort of harvesting. And we got the final pull up on our 2.2 mile right away section of transmission line, which originally was a tangled up mess of cable TV coax. I don't know where the pictures are of that, but it was quite an operation to get that stuff all entangled without getting clobbered by a chunk of telephone pole hanging on the messenger cable floating in space. It was a real adventure. There's pictures of it, but I don't know how to access any of that stuff. So at any rate, we got the pole in the hole, and so now we got pole 0 to pole 56 is all complete. And the next thing out there is to put up the 4,800 foot section of pole pair, which will probably just start with field telephone wire rather than expensive copper and something getting screwed up or stolen. And then there's about another 1,000 feet from the cable TV shack to the terminal of that 4,800 feet. So it's basically pretty simple. It's the whole effort of getting the wire and the antenna up is it's a pretty simple project. The only hassle is moving the ladder back and forth from pole to pole. So that kind of slows everything down, or sometimes people don't want to do that. So right now that's kind of the hang up. But materials are all there. The cable TV shack is ready to accept the equipment. These are the racks the equipment's going to go in. Right now, what's operating is
So they're not seeing this yet. I'm just downloading these
okay.
six that Justin sent me before, so I can at least show these real quick.
So yeah, so that's done. So there's a termination for the 4,800 foot antenna, which is designed to detect the Earth ionosphere waveguide electrostatic activity, which is a very powerful source of earthquake precursors. In fact, on my way up here during a major mishap, which I'm lucky to be here alive, backing the car over a cliff created quite a complication. And but at any rate, I left the AM radio on loud to try to scare the rats away, because that's what caused me to move the car and then end up with my rear end hanging in a pile of rocks. But I heard one of these snap, crackle, pop on the below the AM radio band, around 500 kilocycles is a really good spot. There's something about 500 kilocycles, 600 kilocycles that really taps into what the Earth is doing in some levels. And when I turned it on, that thing was furious. And there wasn't enough cumulus clouds or anything around to justify that kind of electrical activity. And then just like someone took the pot on a mixing console in a recording studio, it just got turned right down to nothing was gone. But those are the ones that thing gets warmed up for about 18 hours, you're going to get a big blast. So amongst all the consternation and injury that I was suffering, at least I got managed in the midst of it to catch the earthquake signal. So that's what's going up down there, is something where it's not just, a car radio or what have you, but it's a piece of equipment. And then the VHF beacon, we have a VHF beacon for propagation study and basically for intercommunications between ourselves. And then there's a network all over the country of these weather transponder units, and we have one of those. They operate in the amateur radio band, so it's very popular amongst the hams. So I don't know if there's anything that involves a computer or digital. I have no idea what's going on, but you should be able, unless it took a SWAT again, but it shouldn't after all the work we did on it. You should be able to get it on your computer, and you can tap in and it'll give you the wind direction and all the things that are going on up there. And then the next step will be to try to figure out how to get the ionospheric signal, at least as a graph or something like that, or however that format works, and get it so that we'll have one thing in addition to the wind speed and humidity. And so basically that's the primary objective there right now, is to get that all operating. We have the terminal pole up at the mine. That was almost a magic act to get that thing in the air with no resources, but we did it. And so now the communications lines and the power can be connected. So that was the next step. In the photographs, you can see that the power company put up their pole, and then we have ours next to it for them to connect to, and then all the antenna lines and everything along that 2.2 mile right of way will come and terminate at that point, because that's the mine where the seismographs are at. So that is basically supposed to be the central node of this whole system. And then all the lines up on the cross arms are patchable to either become antennas or capacitors or transmission line sections, waveguides, telephone lines, communications lines. There's nothing being committed because it's all kind of experimental. And on the other level, the 2 megacycle transmitting coil experiment was outrageous success. So now that needs to be physically finalized so that the thing can operate out there in the weather. And then the next big effort there, and it will be big, is I have the proper Joint Army Navy transmitter that goes with that. It's made by Technical Materials Corporation. They made a lot of stuff for the Navy. It's their 1 kilowatt HF transmitter. So I've got the remains of a couple of them. Some idiot left them out in the desert for 20 years, along with the Collins, which I think anybody that's been following me knows what the Collins is. It was all in the pile. So last episode, not this recent one, but the last one before that, I pulled that stuff out, and we can get it working. It'll be its own project. But that will put 1,000 watts into the transmitting coil, and then the difficulty will be, what frequency we're going to operate on. So we'll probably start off in the ham bands until we can figure out a way to get it licensed and allocated as basically as a propagation and navigation beacon, because that's really all it's going to be to start with. Is it'll send out, like any type of geophysical data or what have you that's relevant, and just to keep it on the air, sending a Morse code signal. Otherwise it'll just send this, the normal da-da-da-da, da-da-da-da, da-da-da-da. But then the experiment will be see who picks it up and who doesn't. It'll be on all the time. So that's about all that's going on down there right now.
So I can show these pictures real quick. And
Yeah,
I can give
yeah.
the link where they can check out the beacon.
Yeah.
That-
Okay. Yeah.
Okay.
However you want to do it.
Okay, so let me just show these.
Is Justin still there?
He's muted out. He might be trying to,
Okay.
he had low bandwidth. He might just have a bad connection
Okay.
where he's at. So let me share the screen real quick.
So I am still here. I'm sending
Okay.
that file across via Signal, but it's moving really, really slow. So
Okay, let me,
I'm here and I can comment.
Okay.
okay.
Well,
Now,
you probably best to comment on this because you were the one doing the most wrenching.
All right.
okay, I'm gonna show the pictures that you sent me already, Justin. Gonna start with that one. Can you see that okay?
Yeah, I got that. Okay, so there it is. This is now both radios. You can see the 2 Kenwood radios that are in that rack. This equipment was provided by Scott Hensler, Steve Young, maybe some other folks were involved in this as well. But it wasn't implemented correctly, and it was having trouble. It kept kicking itself off the air. It was unstable. So the first effort was to pull all this equipment out of the shack and actually fix the shack. So there was quite a bit of carpentry that had to go into this. And this has been a multi-year endeavor. I could actually show on my video. Well, I won't do that because I'm trying to send this file along to Aaron, but the state of this shack when we first, EPD Laboratories first acquired this was really rough. And some of you guys have seen some pictures and documentation of that. But this is now, the shack been totally rebuilt, painted on the interior. It's got RF shielding wire. The whole thing is RF shielded wire on the inside behind that plywood. And so we really had an attention to detail on this. You can see the ground bus out in front of the rack on the right-hand side of the rack. And that is bonded through the plywood to the RF screen behind it. Hakase's built that RF panel. You can see that bulkhead in the background behind the rack. So that's now a legitimate connection through to the outside of the building. That's the antenna feed lines for both of these radios are transceivers. And so This was a big effort to it took a number of sessions. I was still working at the carpentry aspects of this in January and February of this year. And it was great to finally see a conclusion to that carpentry so that we could move on to more of the technical aspects. You can see it's lit up in there. So the shack now has a legitimate power system, 12-volt solar power. And I managed to get these incandescent bulbs from the Napa, which is really the perfect thing to put in there. They're just work lights. We don't leave them on all the time. We don't have the battery capacity for that, but you can really now see what you're doing in there. And so with this implementation, this should be reliable and stay on the air. If you want to move on, Aaron, and show some of the other pictures of the inside.
This looks kind of like the lower section of it.
Justin, just a quick question, if I could, is all the radio equipment there, is that all powered by solar cells?
Yep, that's all. We have one. If Aaron, you want to move on to the next frame in the series, or I mean, it's thumbnailed there. I can see it on the left next to it. The picture of the battery is the next one over. If you could show that picture.
So it sounds like you're lagging because I got the picture of the server rack, and at the very bottom is the battery.
Yeah.
Your video is current. I can see you guys moving around, but the picture that I've got is the previous frame for some reason.
Adrian,
Yeah, me too.
Adrian,
me too.
You don't see the screen share?
No,
Same.
well,
It hasn't changed.
I can see the screen share, but it hasn't changed from the first slide.
You don't see a battery down at the bottom?
No, it's still on the first slide.
No, it's still on the first slide.
So I guess it wasn't bandwidth. It must be a bug in the system.
That's
I guess there's another thing we have to fight.
Well, you can see it thumbnailed there. It's unfortunately it's kind of small, but you can see it thumbnailed. There's the battery.
okay. I just stopped the screen sharing. I have pretty high speed. I got 1.2 Mbps speed here, and I shouldn't be having these problems.
There we go. So there's the first slide.
Yep.
Right. Can you see the one with the battery?
There
Yes,
it is.
Now we can see it. Yep.
Oh, good.
Okay, so that was the battery that was provided by Steve Young got us that, and it was originally implemented in a little funky toolbox that these guys put together. I mean, thanks to them for their efforts and what they did and getting this thing actually up to a point of being working. But like I said, it was unreliable with the configuration the way it was. So it was really worth the time to take all this stuff out and completely revise this. Everything that you see was inside of a couple of cheesy toolboxes, basically. And we've taken it now and implemented this correctly so that this will be robust and stay on the air. You can see also in this frame, there's the right-hand side, but there's also a left-hand rack as well, which is empty, basically. I've just got one shelf in it as a kind of a work table.
You want me to forward to some other pictures?
Sure.
Yeah. Okay. This view, do you see it with the light bulb? And
Yeah.
Yeah,
So
now you can see the panel there. You can see that there's a second rack.
So that second rack is provided and available for the future equipment that's going to be installed in there. That'll be to connect with the lines and have that terminate at the shack. And so for the next push on this project will be to build the open wire line, pole pair only at this time. And like Eric said, we're going to use field telephone wire. And we had started at the other end. This is about 1.5 miles long section of right of way that we have. We had started at the other end back in 2017. We actually put wire up 2016, 2017. We put wire up on this section of line. And unfortunately, we were experimenting using this field telephone wire for this purpose. And we strung it up too tight and it ripped itself apart. It just, the preform grips and the wire itself couldn't handle the strain that we had put on it. So we're going to try again and a little bit simpler this time because we're only going to have the pole pair. Last time we had a more elaborate arrangement, but our intention is to put up this entire 1.5 miles of pole pair with the field telephone wire, and that will terminate at the shack in this rack, which is in this frame. It would be on the right hand side because you're looking at the back of the rack. So I just wanted to point out that, you know, the fact that this is now the way that this is built, it's basically ready to be expanded. We're going to need to procure and implement a 24-volt power system to power that equipment. So that will be, you know, additional to the 12-volt system that we currently have. Aaron, if you want to go into the next.
Okay, are you seeing all my thumbnails on the left side?
No.
No.
You're not. Okay, let me stop that again. I have all the pictures here now from Justin. This is a Zoom issue, because it's showing me that it's sharing, but if it's not, then maybe
We could see the main slide, Aaron, but that was all.
you want me to go to the other shack pictures, Justin, or just start at the beginning of the show?
Let's keep going.
Yeah, I don't know what's redundant. There we go. Go ahead.
It's working fine.
Do you see
There we
the
go.
do you see the hilltop with the trucks?
I see the hilltop, and we also have your thumbnails on the left. So the hilltop picture is
Really?
small.
Should only be the hilltop picture with no thumbnails. I maximized
Now we see
that
the
one.
well, we see the thumbnails as well now.
I don't get it. Just
Has anybody ever had an engagement with digital technology that doesn't have a fight?
From time to time, yes.
You know, is there? I don't know. I won't touch it.
Well, the thing
Anybody-
is, if it's
has anybody
constantly
experienced
changing,
an interaction with digital that is going to fight? It likes to
the
fight.
problem is that historically the word stable means something that's constant or unchanging. And because the technology, because the stuff's changing by the hour, somebody will push a patch, a modification, something to the Linux backend. Everything is constantly unstable. And the more and more often and the more constant everything's changing, the more unstable everything becomes.
Well, that means it'll crash. Maybe that ought to be good.
Yeah.
okay. So do you see the thumbnails on the left with the big picture on the right?
Yes.
Yes.
Okay,
Yes.
I'm not going to maximize it
Yeah,
anymore.
let's just go with
because
this.
what it's telling me that it's showing you is completely different from what you're actually seeing. So Zoom is just
Oh,
simply
fantastic.
defective and it does not work. Okay, so here's the hilltop with the trucks.
Okay, great. So this is a good kind of an overview that shows the facility. And this is the facility that was granted to EPD Laboratories in 2014, I believe we took possession of this. This is our right-of-way grant. This is the Hilltop Terminal Shack. And so the pictures that you were just sharing a moment ago are of inside of this building. And you can see my truck on the right-hand side with the dead end pole in the background. So that is the terminal pole of this 1.5 mile line that I'm speaking of. You can go on to the next picture.
Please tell me that changed.
Yep.
Did.
Okay, so this is just, I wanted to show the level of detail that we took this to. The shack is insulated, as you can see in the back. This wire serves dual purpose. One is as an RF shield, the other is as a rodent barrier. So this was the rat shack when we first got possession of it. And you can see there's a structural hold down clip there, just to the left of that bolt. You know, so I took the time to actually fix the structure and anchor this thing down as best I could, so it won't blow away after we put all this work into it. The bolt that's going through is what's holding the mast to the side of the shack, which also helps to just brace everything up and provide structure there. So just wanted to put that in the frame just to show the level of detail, the level of attention that we put into implementing this. You can go on to the next one. So, like Eric said, this is it's complete now. We've had along the way, we had to rebuild sections of of this. We had missing poles, we had rotten poles. So this is the pole that I acquired from my place up north and brought down, and we put that in. And so we now have every pole up. Not that there's not more poles that will still want to go up in the future, but at least we have an intact pole line for the entirety of the line. Next picture. There's a good picture of the shack in the background. And so what's really encouraging about this is that we're no longer in a situation where we've got to dig a bunch of holes and try to lug these poles around. Anything that'll be done in the future is we're going to hopefully hire done what we need to be done, and not have to do this the old way off the back of the pickup truck. So this is a very encouraging moment to see all this stuff up in the air. Go ahead to the next one. So while we had the whole crew here, it was really great to have just the enthusiasm of everybody being together, and then also the physical force of all five or all four of us. And then there was the sixth, fifth and sixth were the Steves that came. But it was really a big effort to get this this pole up that was at the mine, at the seismograph facility at the mine. And so here's simultaneously we were putting up poles, and also the telluric platform was getting built and tested out. So next picture, please. This is the effort to stand the pole at the mine. And
it was an effort.
We had to get very creative because we didn't have what would be considered, the normal equipment for doing this sort of thing. And the pole that was just shown a few frames back, that was the pole that I got and I procured and brought down here. That pole, almost the same length as this one here in this frame, I was able to load that on my pickup truck by myself. This pole was incredibly heavy in comparison. There's a big difference between those desert dried out poles, and this pole was actually a brand new pole that was purchased for this purpose. So we had to use simple machines. We had to use come-alongs to load this thing onto the truck. And then when we went to push it up, usually Eric and I can stand a pole by ourselves right off the bed of the pickup truck. But that was not possible. Even with 4 people there, it was not possible for us to push that thing up. So we had to build an apparatus and use the force of the pickup truck to stand that pole. And next picture on that. Just a quick view of what that looked like and how we got that straight. And you can go on to the next one. So here is now our set of terminal poles at the seismograph mine. And you can't really see the detail, but we're looking across at the distant ridge top is where the shack is located. So this is kind of an overview of the whole project. This isn't quite pole 0, but it's oh, interesting. Somebody just commented on something, but I don't know what. At any rate,
we're located parallel to pole 17.
Yep, pole 17. So there is a bit more of the line that goes back towards town, but this does represent a pretty good overview of what we're talking about. And what we're intending to build would be the section, out there that you're looking at in the desert, terminated at the shack. This is an alternate termination point, and obviously the seismograph equipment is here. So the power company was kind enough to rebuild this line to our specifications. And now that we have our customer pole up, we're ready to put our metered service on it and have the power company hook us up. Next frame. So this is actually pole 0. And this is the other end of the proposed line. As far as this is where our line and the telephone line will meet at this point at pole 0. So that's really the full project overview. You can see it is quite a bit longer than the termination at the mine. So now we're going to move on to some more pictures of the shack. Aaron showed some of these, a little bit redundant just because I wasn't able to get that file uploaded to him. But this is the RF bulkhead and our terminations that go through the shack wall from the outside. You had seen a picture of that earlier. Next frame.
Justin, just to confirm, you have a pair of parallel wires there up on the poles. It's a pole pair up on the top, huh?
Oh no, so that's what's proposed right now. What we have is we have our radio frequency antennas on the poles.
Okay.
So what you're seeing in this frame is me assembling the voice repeater antenna. So this will also serve as the dead end pole for the pole pair, which is proposed to be installed for our next session.
Mm-hmm. And the pole pair will run the full 1.5 miles?
No,
That's our intention.
It's still, the whole thing is 2.2 miles from, this is pole 56 and pole 0, you know, that's the beginning of the line and this is the end of the line. But it's 1,000 feet from pole 56 to pole, I believe, 49, which the 4,800 feet of antenna, which dead ends on pole 26. So there's supposed to be 6 conductors altogether. So that constitutes pretty much 5 miles of wire. So we have the copper wire to do it, but we're not going to put that copper wire up in, you know, in any kind of half-ass situation. That's got to be all. We don't have the insulators. We still got to get cross arms, but to build the antenna so that there, when you say pole pair, probably people wonder what we're talking about. When you have a cross arm in the old open wire glass insulator telephone stuff, you have the carrier pairs, which was the radio frequency stuff that carried the voice multiplex, which was usually on the outside of the arms and had numerous points where there was a special insulator bracket that twisted the wires 180 degrees. There's one pair in the middle called the pole pair, where one insulator is on one side of the pole and one insulator is on the other side of the pole. And that's kind of the supervisory or talking pair, or it could be just a regular voice frequency telephone line. Maybe a simple multiplex, but it has bad impedance characteristics because you have the pole in between the wires. But it's the easiest to work on because you can cling to the pole and not have to hang out in space on the ladder or keep moving the ladder back and forth on the 10-foot arm, which I think maybe you might get an idea how labor intensive this stuff is. Sometimes after an episode, you might just drop with exhaustion. There's one hole we had to dig, a 4,000-pound strained guy anchor hole. And it took Justin and me 2 days, and I was in a lot better shape back then. And we almost killed ourselves on that one.
So there's some pictures coming up in the slideshow of some of the completed work that we had done. Let's just keep moving through this.
Okay.
So there's a redundant picture. Actually, that's before it was really wired correctly. You can just move on.
So that's the inside of this one.
Yes. And this is just, this stuff is now temped in. This is kind of halfway point. Assembling the antenna, that's the voice frequency antenna, and going up. And then this is our, how would you say, our line. This is our feed line between the dead end pole, and you can see on that mast out on the shack, that's the APRS, that's the weather station transceiver antenna. You can move on. So this is a good view of the outside of the shack. You can see basically this is our whole facility at this point. Solar panel on the roof. There's more roof space there for the 24 volt solar panels that we'll want to configure. You can see the rack inside the shack and both the dead end pole on your right and the mast centered on the shack, and then the weather station itself that records the data. Go ahead to the next one.
And before we go on, Eric, can you paint a picture for everybody who doesn't know what a lot of this is about with the shack, the shop, the seismographs in a mine, and all this wire? You know, kind of like a diagram in their mind of.
Well, that's what I
what's
was
the
kind
purpose
of
of all
doing,
of
but I
it?
think it's best we follow along with this
Let's keep going
first,
with
and
that.
then, you know, then I can outline that after there's more pictures of what's going on.
Okay, so we kind of already went over that. And that. And that. Okay.
There you go, that's both antennas.
Another good overview that just shows, you know, what equipment we've got up in the air as well as on the ground. And then you can move on to the next, which will be, these are some of the photographs of our completed line. Now, some people have seen these. These were in some of Eric's earlier presentations. And this is a line that we rebuilt this to secure it from damage and to use it for test purposes. And so we did accomplish what we had set out to do. And this is a view of what the final finished product would be. And you can see the strain insulators there on the open wire conductors. And the reason for that is so that the whole thing is mechanically connected, but is electrically separated. And what we have here is the ability to patch and have a different configuration. We can change the configuration of how these conductors interact, whether they're all looped together, whether they're zigzagged, whether they're all, you know, paralleled together, what have you. It then becomes an experimentation tool. You can move on to the next. So this is the facility that we're currently talking about. That's here outside the shack, outside of the shop that terminates at the shack. And this is an example of the field telephone wire. We put this up and it broke. And this was our first attempt at repairing what had broken. So, you know, we tried, but it was an experiment and it didn't work. And we learned a lot from it. So we're going to do it better this next time. You can move on.
Justin, just to check, it broke because it was too tight?
We believe that it broke because it was too tight. This is not, you can see the U-bolts that are by Eric's hand. That's not phone company stuff. What we're used to dealing with in the previous frame, the really, you know, completed line, that's number 10 copper weld. That's a whole different kind of wire. And we actually have on the shelf right here, I've got the preformed grips for the number 10 copper weld. And we attempted to buy number 10 copper weld. I guess it was cost prohibitive to do so. So what we have is we have 5 miles of hard drawn number 10 copper, which will fit in these grips. And, you know, when we talk about pole pair and we show the photographs of this other completed facility, we're trying to illustrate that we're going to take this thing in steps. What are the realizable steps? You know, we don't have the budget, the staff, or really the proper equipment, like Eric was saying, to get out on the outside pairs right now. We've done that before. We've done it from ladders. We've done it with pole climbers. But really, that is a major project, and it would take months and months, and we just simply don't have the time and resources to do that. So what we do have the time and resources to do is to put up this field telephone wire as a simple pole pair, and then that'll allow us to begin to demonstrate. That'll allow us to have something that will actually be terminated and function. So more pictures of the what we call the distant line, and you know, just showing how it can be done from a ladder. It's just very difficult. It's very time consuming, and there we go. So this is an interesting shot right here where you can see the outside pairs, they're being terminated on their dead end insulators, and you can see the pole, what we call the pole pair, continuing on from this point. So this gives a really good example of what it's going to look like in the different phases of first pole pair, And then later on, as we have resources and time to do so, our intention is to put up the outside pairs as well. And one thing I should mention is that on the proposed line, most of the cross arms are also up at this point. So a lot of the heavy lifting has been done. And it would be possible to do the entire pole pair from the ladder. It's just, like I say, it's so labor intensive and time consuming that what we really want to do is procure the proper equipment. And I did make contact with a contractor here that's a lineman for the telecommunications company. And I got the contact for the boss to actually have him try to estimate what would it cost to just hire them to come out here and do this thing right. So I have no idea yet what the range of that cost is going to be, and it might be cost prohibitive, but we're exploring all of these different options simultaneously.
And the pole pair, and Justin, the pole pair runs all the entire length of the pole arrangement and then loops back on the outside. Is that the intention? So you get a lot longer wire length.
You could configure, this is going to be sectionalized, this whole line.
Oh, okay.
So at various places along the line, it's going to be sectionalized like what you see here in this current frame. And so, you could configure this in a number of different ways. I don't know how many possibilities. Eric would know that.
Very cool.
Right, and the rest of the pictures are original ones that I showed that you sent me.
So
And
the one other,
that's the last one.
there you go. That's the one.
The last one's the first one.
Yep.
That's what we inherited.
This is the shack condition at the issuance of right-of-way
The rat
grant.
shack,
If that's what you want to call it.
the rat shack,
The rat shack.
including
So-
the two-legged rats.
So thanks for that. I'm glad that actually went through and we were able to get those pictures shown. We've got right there a lot of historical documentation of proof of performance of what we've done, and everybody can see the continuation of this project. And it's repeatable. We can keep going with this. We just need to secure the funding to continue the operation. So that's the end of my presentation.
Okay, and there's one link that I want to show, and that's the one for the beacon where people can see it on the internet, the location and all those details. Let me show that real quick, and then I'm also going to paste this link. So if everybody wants to check out the chat, I'm going to post a website address in there. And then I'll show the screen of what it looks like. Hold on a second. Screen share. Can you see that right now? aprs.fi?
Yeah.
Okay. So that link is in the chat, and I'm gonna kind of already went over what it's about and everything.
Yeah,
But
yeah.
this is where people can actually kind of tune in.
That's what I want, get an idea, so enough people. Well, there's actually, when we have this thing going, some of the universities were using it, because this is the only one around in this area for quite a distance.
You can see Eric's call sign on there, N6KPH. Kind of a well-known one. Okay, and as Justin was saying, we definitely need some funds. EPD Laboratories Inc. is a 501c3 nonprofit corporation, and all donations are tax deductible. And let me bring up Eric's website so you can see how to help out here. So at ericpdollar.com/donate, there's a PayPal link here. There's a mailing address here if anybody wants to send checks or money orders. It's a Spokane address for me up here. I just endorse the checks and send them down to the bank in Nevada. 95% of the time, people just use the donate by PayPal link. If anybody can pitch in anything, I think there's an option when you click that it would actually, you have an option to even do recurring. even if it's $5 a month, $10 a month or more, you can click that little box right there and make it a monthly donation. It's been an expensive several months, not just, up here. The project up here was pretty much on my dime, but all the stuff going on down in Nevada and down at the shop with everything that Justin just showed you is pretty much funded all by donations. And Eric has even paid, out of his pocket from some of the Social Security money to help make it happen. We do what we can with the donations, so Eric doesn't have to do that. So anything that anybody can pitch in would be greatly appreciated. An angel funder who wants to donate $10,000, $20,000, that would give a big chunk to, do a next few episodes. But you can see that all the donations are definitely going to where it's supposed to, and this is helping to expand and keep pushing forward all the work on the electrical sciences, if you just want to group all that together under one category. And I don't know if anybody else has anything to share or anything.
Oh, yeah, we got plenty.
Okay. Before we open up for questions.
Yeah.
Yeah, well, go for it.
Because now I'm here.
Yeah.
Yeah, you think that was hard. Try this out. It might be all on the bench, but it's the same number of pieces. But yeah, so the effort right now is
Right back.
what we have codenamed the burning bush. I think that's something that a lot of people still remember what the real meaning of it is. It was a biblical term. And so in general, I'm pretty much done with all the electrical mathematics at this point. The heavy side stuff that I put out and that is going to get put out finalizes it. So, and Griffin has about 1,000 pages of finalized publishable material. So I'm done with that. And the polyphase mathematics and what have you, I'm still interested in that more from the Pythagorean standpoint. So, but again, I've pretty much completed developing the whole basis for the thing. And now this upcoming presentation of 4 phases, I don't really think anybody, I've never seen it, has done a Fortescue analysis on a 4-phase system. And so I decided to jump in and do that because I have the Fortescue thing pretty well worked out. It was not easy. It seemed to take another level of interpretation, but it gave the right answers. So that's a good first step, but it's still a little fuzzy theoretically. But my main emphasis right now is on the music stuff. That's going to be pretty much my primary focus. Most of the effort is going to be on Bach and all that. And of course, I'll still be involved, with these radio transmitters and all that kind of stuff, because that's something that I like to do. And that's what I'm building here from scratch. So the reason why I brought up the burning bush and the music thing is there's this thing, the musical flame or the flame speaker situation. So I think it's already, Adrian kind of already talked about, we got the first step of that and we got it up to a decent volume. But the missing element is there's no video. Now, of course, somebody would ask, well, what is video? What video? How does the video get in there? Well, there has to be a special modulator that introduces a video type signal, which is derived from the audio going in, but it is no longer the original audio. It has harmonics are shifted around and what have you. And because it has even harmonics, 0 is an even harmonic. So 0 is 0 frequency DC. So what that does is then the flame doesn't just sit there dead when there's no music. It goes away. So the amount of firepower you have is proportional to some waveform derived from the music that also represents the amplitude of the music. So the louder the music, the bigger the firepower that then makes the so-called flame. But at that point, it won't be a flame anymore. It's going to be some kind of fractal pattern. I don't know exactly what it's going to be like, but we did something here the last time I was up here is Aaron had found a recording of bird songs, which is really suitable for this setup we have here, because it's kind of a single frequency set of harmonics rather than complex, and the frequency's high. And to see that flame, the burning bush, just sitting there silent, and then all of a sudden a rather loud bird song come out of it, really seemed to have quite a impact on people.
You have the videos for that, Aaron?
Not yet.
Not yet. Okay.
So at any rate, when I was at Santa Barbara, I had built a 5 kilowatt unit, which is about twice or 3 times the size of this, and I'd done all this, and it was absolutely beyond comprehension. So basically, I got this flash in my head with the bird signal thing that's got me more intent on finishing this particular setup. So that if there's no flame or no fire, no burning bush or any of that kind of stuff, and all of a sudden there's this bird chirp and this geometric pattern erupts, which is making the noise, and has some kind of shape associated with the bird sound, or for that part, even a violin or what have you, I think that would be probably one of the most mind-boggling things that anybody's ever seen. It's not computer-generated imagery, it's reality. And that brings me to another point. This is derived out of what I call the music television project, which I really don't have the facilities to put together right now, even though I do have all the parts. And I think anyone that's fooled around with an oscilloscope might know that when you put the vertical on the right, let's say, and you put the horizontal on the left, you get what in television is called a raster. In other words, the scan on the TV screen, if there's no video, it's just this white or black or, some intermediate level of gray that is blank. So now when you do this with the music on the oscilloscope, I mean, if it's just 2 sine waves, it's going to make an elliptical rotation type thing, circular. But when it becomes like Bach organ music, it starts to get really exotic. Particularly the orchestral music of Handel makes the best images. But basically, it's a raster. It doesn't contain any information. So what I developed at Landers with that massive system I have there is I came up with the video modulator and put that into the cathode of the CRT, so that first of all, if the signal was not stereo, it would not produce any brightness. And second of all, the brightness was all second order or even order based. So it had the 0th harmonic or DC. So when there was no music, there was nothing on the screen. And then when there was music, then the cathode of the CRT could start to emit proportional to the video waveform, and that modulated the raster, and then this image came to life, literally came to life. It actually, one person was scared when she saw this thing and ran from the shack. So this goes back, there's an Italian musical guy, I don't know. This is all in that book, Music of the Spheres by, what's his name? Jameson or?
Yeah. Jamies or something like that.
Not the Guy Murchie physics fraud stuff. It's Jamin something. But at any rate, he covers the whole history of musical philosophy, and this Italian Fici was his name, and I've actually experienced this in Grace Cathedral during an organ concert in San Francisco. I could perceive it. Is that an entity kind of forms out of this musical performance, which was a lot different then than it is now. Just like the music television makes no image whatsoever on what people call music now. It's image free because there's no life in it anymore. There's nothing to see. It's just dead, skeletal at best. So he called this thing an anima, and I'm getting the idea that with these primitive systems, which were actually highly advanced, primitive is the way we would look at it, of the shapes of the cathedrals and the harmonic balance, and they would build like these little reflectors and resonators and what have you, is first of all, none of the energy out of the organ can leave the church, nor can it be dissipated in the heat or what have you. other than, you know, if it's packed with people, they absorb a lot of the sound. So this thing produced an entity within the volume of that church, of course, depending on air pressure and humidity and what other cosmic polarizations, which definitely exist. I perceive that. So basically with the so-called flame speaker or the musical fire, let's say, or because it's not a bush anymore, and getting this thing on the CRT, I now have the special CRT assembly to do this with. That's my main interest in that area. So basically, what I'm working on here is to get to get all this stuff done as far as we can this time around, and then there's one piece of equipment that has to be built, and that's a CD player. So we have to take a car stereo and make it rack mount and RF proof, and it has to have its own power supply. It's got to be in its own cabinet, and it has to fit in a given space in the modulator bay, replacing the HP audio oscillators. So it's interchangeable units, and then we can. That's how we're going to get the music into the burning bush when this is done during the presentation. And in the meantime, I'm working on the grid control unit, which has the video modulator and the RF driver and the bias and screen grid and all that type of stuff in. It's extremely complicated unit. Well, actually, let me just grab it. Oh, this cord would be here.
Yeah, go around. I got those things charging. And we'll probably do another full walkthrough after Adrian's here, and we kind of get a little bit more progress on that. I think we're going to do another live call on around the 15th or something like that.
Yeah, that'll be good actually in July, Aaron, because I'll be actually there in the shop, so we can do that video properly walk through.
Okay, here we go. So this is the front panel is being painted. Here's the back, which is not much going on there. Then the inside, you can see this is not just some kind of simple little ham radio project. Yeah, got to get it all to fit in there and what have you. It seems to be kind of bring the screen up more. Yeah, like that.
Yeah, that's good.
So this is the back. So it's modular. So the various units come out. The power supply does not need a shield, nor is there enough components to justify a double deck deal. Let me give you the double deck. Where's the camera hole?
Right here.
Okay. You can see the double deck deal. All that comes apart. It's a wiring harness and it folds out, so you can work on it and change the parts. And then the modules are removable. That's the back. Let's say the bottom. And this is the top. So you can see on the right-hand side is the rectifier, and then on the left-hand side is the audio amplifier and harmonic generator for the video, and then the tube sockets down below. Those hold very high-speed, fast-switching mercury-wetted relays. And that does the rectangular wave modulation, which makes the fractal discharges, and it's highly controllable. So the front panel is not here right now. So this is takes a lot of figuring, and that's what I'm working on right now, getting this thing, because there's nothing else I can work on other than the presentations, which actually is its own big project. The music thing's been massive. So I'll put this back. So that's pretty much what's going on, what I'm doing here.
Anybody else want to add anything? I know I saw Bruce Gavin logged in. I don't know if he's still on there, if he has any updates, or otherwise we can probably open up for questions. If anybody has any questions. If anybody does have questions, at the very bottom of the screen, there should be a reactions icon. How much of the work could be done from a boom truck? Does the terrain make it suitable? Yeah, I mean, if somebody wants to donate a truck or help with the funding to get something like that, but it's
Yeah, it's about 25 grand altogether.
out of
You
the
guys
reach.
talking bucket truck now?
Yeah, somebody was posting about it. That'll have to be down the
We've
line.
looked into, there's a number of different ways, and I'm thanks for the question on that. You know, we're still trying to determine what the hardcore costs of this is going to be. And now that I've made a contact with the contractor, we'll get that number and we'll use that number as a reference point. Now, I kind of expect that it's going to be too much to hire the contractor to come and do it. I expect that we're probably going to end up trying to tackle this on our own because we've done a lot of this. The big upgrade would be to get a bucket truck. And we've looked into renting a bucket truck. We could actually go that route. There's a complication of a CDL, a commercial driver's license is needed. And I don't possess one. I've never had one. So there's a complication on that end, but it certainly is equipment that could be rented. I think that if we can come up with the money to buy one from auction, you know, there's the utility companies time these things out before they're really expired. And we could pick up one of these trucks. I estimate probably $5,000. We could pick one of these things up at auction. And then not only would it get us through this project, but what we've experienced in the past is, you know, there's a maintenance consideration to this stuff because it is still experimental in its nature. And we're taking this thing, you know, piece by piece. Owning the bucket truck, I think, would really be what would make us able to build and operate that facility. So that's something that I can look into and you know, put some numbers forward. I'll be happy to share those numbers once I've talked to the contractor as well.
Is it possible to get a lower cost option, like a little trailer with some type of scissor lift kind of thing? That might be, you know, 1/4 of the price, or, you know, something along those lines?
Well, you know, the scissor lift is a potential idea. I've rented a lot of machines and you can haul them with a standard pickup truck. I have the pickup truck to haul the scissor lift. That's something that, you know, coming through one of the bigger cities around here, we could pick something like that up. The main challenge with that, with a rental unit on that, is going to be getting something that's 4-wheel drivable and can deal with the severity of the terrain that we have out there. So there again, you know, I'll look into some of those options and then just submit the pricing for, you know, what does everybody come back with, and then we can make a determination from there.
Yeah, and even these low cost ones like that eBay one just mentioned in the chat for 7,000, there could be $10,000 in maintenance that needs to be done on all hydraulic lines and stuff like that. So knowing what the actual condition is.
Yeah, that's why I kind of just off the top of my head, it feels like if there's going to be a bucket truck, there's going to have to be $25 kilodollar fund, so to speak, to draw from. So you don't end up running out of money in the middle. Then you got something sitting in the backyard that doesn't work. You got to be careful about that. And then insurance this day and age, holy Jesus, that's that'll probably be as much as the price of the truck.
So the insurance consideration might actually drop out because this isn't an on-road vehicle. We're not going to be taking this thing on the highway. It's just for the line here local.
Well, that would make it, then it would be cost effective.
Yeah.
Yeah.
It's basically an agricultural piece of agricultural equipment, or, you know, I'm sure through EPD Laboratories ownership of it, we can just exempt that thing. So at any rate, I'll look into the cost of some of these things and just get back with some numbers.
Okay. And then somebody is asking, Anna is asking about kind of an overview of the project.
Which one?
Which so with the so-called telephone poles and all the lines and stuff with the shack, and then next to it, roughly halfway, is a mine that a university down there basically gave rights to EPD Labs, basically gave these seismographs. There's 3 of them in there that was used for earthquake monitoring purposes. And
let me dwell on that a little more. So So basically, we have an absolutely fantastic 3-axis seismograph transducing system 100 feet into solid rock in a horizontal mine shaft, which is a priceless, absolutely priceless asset. But then, you know, there's the terminal room to put the amplifiers and the patching, and the portal to the mine is not safe. And I can't even begin to imagine how much it would cost to get all that together. Right now, our emphasis is just to get power and telephone to there. So basically, there's 3 points on this 2.2 mile of line, actually 4 that are of significance. So there's the pole 0, which is the signals back and forth to town and to the building, and for the town to have the seismograph to actually see this stuff. And then there's the musical seismograph thing, which is a version of what I just talked about, where you can actually reproduce this anima, but it will be the earth, it'll be the inside of the earth, and you'd be able to listen to it, you know, over the internet, which is something like this flame thing I was talking about. Is I'm just dying to hear what this thing sounds like. It's going to be, there'd be nothing like it. So that's kind of the main point on the facility, but the least developed because of the massive cost. So further down the line at pole, that's pole 17. Pole 26, that is the antenna dead end, and everything from pole 26 to pole 49 or 48, I forget which one, is that's all antenna for sensing earth signals and transmitting and receiving out of the ground. And it's at this point, it's a laboratory device, but it's also finalized and engineered enough that it can provide useful data out. The plan is as things upgrade, is not just having a DC envelope on a graph, you know, like a temperature thing on the weather radio, but actually you can actually hear it, like the stuff I heard in my car radio that night. So that is kind of an end objective.
So this is good right here.
Because we don't have the terminal equipment at the mine, we're using the cable TV shack because that's fast, cheap, and easy. So that's pole 56. So pole 56 is the shack. Pole 49 is the end of the antenna. Pole 26 is the other end of the antenna. Pole 17 is the diversion of the mine, and pole 0 is the whatever carries the signals in the town. Probably start with the phone company. So that's kind of the general diagram of what we're doing. If there's any more details or what have you,
if I could comment too,
Go
Aaron,
ahead.
if you'll bring back up the cover of the book that you were just showing, the that has the landers charts there.
Oh, yeah, you have that.
The electrodynamic
Yeah.
seismic
Yeah,
forecasting. Okay, so just give me a second here. Can you see that kind of zoomed in?
Yeah, that's perfect. So what I wanted to point out was that this is at the top, this set of charts above the photographs is that's a reproduction of the landers charts. So as in terms of a whole project overview, this shows the comparison of various facilities. Like, you know, one of these is a seismic transducer. One of these is the overground. One of these is the underground. Eric could explain that better. The pictures below is showing some of the test and demonstration that we did when we finished the line here locally, you know, quote, finished it for that session. Before the wind tore it apart, we went out with the car, and this is the equipment in the back of Eric's car, using that for the test purposes. So in terms of project overview, I wanted to point that out and point out the comparison of these facilities. If we were able to take it to the point where we had the developed overhead line and terminal facility at the shack, and it was tied to the seismograph mine, and all of that was able to be brought back into town, it would be absolutely fantastic. So we're trying to just take it piece by piece for what we can realistically achieve with the resources and the time that we have. So I hope that helps us in terms of a project overview.
Let me show any landers pictures on your website so people can kind of see the.
Yeah.
Okay, here, hold on. Let me show. So Landers is a town in California near the Integratron where Eric had a massive facility that was for seismic forecasting and a bunch of other experiments along these lines. Let's see, Landers. So what's going down in Tonopah is an effort to kind of replicate some of what was going down there. And I don't know if everybody can see kind of these all these thumbnails. Are those showing up? Okay, so probably don't have to. Anyway, if you go to ericpdollar.com and if you search Landers in the blog, you'll see a lot of these pictures. Eric built most of this from scrap parts and stuff, kind of along the lines of the type of project with these, you know, RF and audio modulator bays, all these units, and he constructed all this for the purpose of picking up. It was the world's most sensitive seismic forecasting system, and you can even see the vibrations of animals running across the desert out in the distance. That's how sensitive it was. That's not an exaggeration. Let's see. I know there's a couple different posts. Okay, so down here, I'm looking for the charts too, but you can kind of see.
The charts are in that electrodynamic seismic forecasting.
Yeah. So all this is, so you can kind of see the magnitude of this project and what Eric and
So basically, this is what I'm trying to put back together. But now in this day and age, and you know, in my position and what have you, it's not easy anymore. Well, it wasn't easy then either, but it was possible. But now it's the basic social structure no longer exists. There it is. That's a 1 year graphical output, point by point on a day by day, writing down what was the maximum reading on the chart recorders and getting, you know, various data. So the bottom one is the solar flux. The middle is an interactive pair where red is the differentiated signal coming from the overground antenna, and the green is the integrated signal coming from the underground antenna. And it's both of those provide together, you can get a better idea of the location, but both of them, the top one is what I use on the AM radio. No, I'm still talking about the red. The red one's what I use on the AM radio. It's the equivalent. And then the one on the top is I had a basic type of differentiation of the seismic variations, and that would go into an impulse counter. So that is the daily number that the impulse counter read. So the bottom, the solar flux was derived from WWV. The middle bar, that was the underground and overground antenna system, which is what we're again building. Things that you've seen is that antenna. That's what we're attempting to put back together. And the one on the top came out of the seismic transducer, which was embedded in some 30-mile wide boulder of granite out there in the Mojave Desert. That's where the name Giant Rock came from. It's from the rocks out there. And so basically that's the amount of seismic noise is what you could call that, the physical seismic noise.
Okay. So, and then you would say that with all four of these pieces of data put together, when they all start to kind of move up together.
Yeah, plus there's certain frequencies that come to life, and yeah, but things start, and then so basically Griffin right now has it's not all hooked up yet, but he has the compact version of this. Basically, it's pretty much the same thing, but uses very localized equipment. The only reason he can do this is where he's at is because the public utilities in the city and county of Los Angeles are typically delta. So there's very little interference there. So the whole idea is to have two of these stations operating in tandem, eventually to get stereo, but you know, we're talking about quantities of money that are difficult to get. So there's one comment I had about getting the money is nobody that's here right now has really any money to put in anything like this that could make something major happen, but maybe there's somebody that who does have the money to make this stuff happen and would be interested in it. So in my mind, I don't see the people that like we're communicating with now and with the presentations and all that type of stuff. These are not people that have the money. They can keep it going the way we're going now, but I'm 71 years old and it doesn't look like the world's going to last much longer than me, or maybe less. So we need to get the big money to get this thing built. And if there's people that know how to do that, that would be helpful. That's one idea I have of how to try to move this thing, you know, at an accelerated rate to come up with some major completion. And then I saw Griffin's coil. Do you have anything to say about your Alexanderson coil, Griffin, or what I talked about your system?
Yeah, so the small scale Alexanderson coil was presented, I believe, around 3 live calls ago, give or take. And that one proved to provide some decent performance and analysis just to the construction of the Alexanderson loading coil design. It's a rather unusual design by conventional, by modern terminology. So, of course, if you go through the previous live calls, I expound upon its design and just what was found out upon it. So it is essentially designed for telluric research. And to date, we still need to construct larger scale models of that coil design just to see how does frequency and how does coil geometry improve performance just in the general realm of telluric communication.
Now, what about your seismic sensing thing? Can you just give like a little?
Right. So at the present, it simply consists of 2 racks, which I have some pictures of them on my website. One rack is dedicated to all the seismic sensing equipment, and the other rack, the second one, that's essentially going to house radio frequency equipment to broadcast the seismic information on, say, a 2-hour or hourly basis, and could be received by practically anyone in the world based off the antenna setup, which I currently have. Now, the actual seismic receivers, they incorporate some specialty vacuum tube circuitry, which Eric has been assisting me in recently. But of course, due to conference-related scheduling and projects, that's been a bit difficult to complete thus far. So afterwards, after the conference, then that's when we could finally complete it. And I believe that's one of the pictures of one of the seismic receiving antennas. That was the day I completed it. So that I'm sitting atop
Farmer G.
I'm sitting atop the laboratory. It's essentially located in a suburban environment. That's the construction. It's a specialty Marconi flat top antenna that does not really possess any characteristic wavelengths, so that makes it suitable for electrostatic receiving out of the ionosphere. In essence, it acts as a large 20-foot by 8-foot copper sheet suspended around 35 feet in the air. And with a large ground plane, which I have affixed within the local area, we could essentially create a Earth to ionosphere receiving circuit, which Aaron was able to glimpse over, which is similar to the conventional Marconi flat top receiving apparatus. And from my early attempts of seismic forecasting, that has proven as a successful setup, as well as Eric has proven. So that's where we'll be moving forward. And the video that Aaron has his mouse on, that thumbnail, that just shows a portion of some of the seismic receiving pieces of equipment. We have on the right some of the frequency selective voltmeters that, in conjunction with some other pieces of equipment, which are all rack mounted, will be used as the receiving apparatuses. And then, of course, on the other side, the gray rack, like I said, that's going to house all the radio frequency transmission and radio frequency receiving equipment that will get this signal out on the air. and anyone with the shortwave receiver will be able to pick up the information. So it'll be the first suburban seismic forecasting station to date.
And this is all on griffingBrock.com.
So of course, with all the other handful of projects, that's a work in progress, but nonetheless, it's not a dead horse. It will be completed within, I would say, a month following the conference.
So are you going to try to get some level of that on that APRS thing like we're going to do out in Tonopah?
More than likely. So there's still enough dedicated rack space to house such a unit. And of course, Haka says that he'll be willing to assist me in those efforts. So not only will we have an APRS station out, but also a conventional, I would say 40 meter or 80 meter beacon that will broadcast on an hourly basis, give or take. That still needs to be hashed out, but we'll have, and also in conjunction with possibly a live website feed, then we'll have 3 means of outgoing communication for the world to receive.
Yeah, then once we're done out in Tonopah, we got stereo.
Right.
That's the final step, stereo. Then you can get direction.
Exactly. So in overall completion, if and when Eric's telluric site is able to be completed, hopefully soon, that in conjunction with my site, we'll have 2 distant stations which will assist in not triangulating, but some more than likely be able
Localizing.
to direction find where the epicenter of some kind of seismic event will occur. 2 sites to essentially compare results obtained.
Yeah, it'll give a good chance to get rid of noise and isolate a lot of things, because there can be a lot of things that could happen at one station, like Griffin's site, that might not happen in Tonopah. And by doing that, you could separate out the 2 different signals.
Right.
And then all the lines in Tonopah, it's not just restricted to just seismic research. It's all for all kinds of,
Propagation research.
yeah. So it's universal experimental station, not just for seismic forecasting, but for all types of transmission experiments, Tesla related stuff. And so there's a lot of uses for it. Let's see, we're on about an hour, 45 minutes. If we can keep it under 2 hours, 2 hours max. If anybody has any questions, click on reactions at the bottom of your screen, and there's a little smiley face there, and then you'll get a little icon, a little option that says raise hand, and then I can see who wants to ask a question. And then there's no questions, I guess we could wrap it up. Any final words, or
I think that was pretty exhausting.
yeah. And we are, so we're all going to be up here in Spokane at the conference. That's July 5th through 9th. There's 11 in-person tickets remaining. Every conference is quite an experience, and it's going to be jam-packed. So you can go to emediapress.com, and on the at the top of the page, I'll just show that real quick since it's wrong website. Screen real quick. Yeah, emediapress.com. Says the screen share is loading. Okay, there it is. At the very top is this banner right here for the conference. If you just click on learn more, when that page comes up, you can scroll all the way down and you can look at the full schedule. The only edit is Sky Huddleston is not going to be able to make it to demonstrate the small 125cc Bork engine or the 30 cubic inch one, which was the intent. And so we have another presenter who's going to be doing a 1 hour presentation. I don't want to say what that is yet. I just have to confirm. And then we'll get that up on the website. Other than that, nobody has any questions. We have 33 people on the call, including us. But if you have a question, right now is the time. Otherwise, we can wrap it up, and we'll be back on here in about 3 weeks. I think the 15th or so. Going once. Okay, well, let's see. A couple new messages here. If anybody has a question here, I'll read it. So yeah, any of the question about the Rife stuff, it's kind of off topic. If you want to email me at info@emediapress.com about the Rife RPX stuff, I'll be happy to answer your questions in there. This, we want to kind of keep focused on the projects.
Well, Griffin's vacuum tube is a step in the direction of a new type of Rife tube. There is a little bit of a connection.
Okay, so let's go into that for a little bit. Some questions I can't answer if it's relating to the health, wellness, the body, or anything like that. Not even going to touch it. The RPX unit that I sell, which was John Bedini's sideband generator that he developed after his years of Rife research, having a Rife microscope in his hands, Rife's handwritten notes, and so forth. That was one of his passions, was the whole Rife technology, and that's so the RPX is just sold as a research and test device, so you can study how Rife actually made his frequencies and whatever you want to do with those frequencies, but we don't make any kind of claims. That's all it's sold for. But so Rife had the tube unit, which I guess you could say the gas tube unit is basically an antenna to broadcast these so-called Rife frequencies, which there was only about 20-25 frequencies. When you see these lists of hundreds of thousands of frequencies, automatically just disregard it because it's all fake. All that stuff is made up, and Rife was not involved with hundreds or thousands of frequencies. There was about a little over 20 frequencies, and that was it. And they were all created by sidebands, which you have a carrier frequency, just say 3 point whatever megahertz. And if you mix a audio frequency with it, you create frequencies that are the addition of it, but also the subtraction. And those addition and subtraction frequencies are called sidebands, upper sideband, lower sideband. And they had a sweep method developed, which Rife and his partner, Philip Hoyland, his assistant, who did know what was going on because John Crane hadn't the slightest clue. Philip Hoyland developed that sweep method. So the audio frequency goes from a low frequency to a high frequency. So these sidebands become more additive and more subtractive as they start moving away from the carrier, automatically hitting every single Rife frequency sequentially along the way, moving up and moving down in both directions simultaneously, which means you don't need a microscope at that point, because if you automatically hit everything, you don't have to know the specific frequency of anything that you're specifically targeting. Now, Eric had met John Crane in California, and do you want to explain what you saw?
I was in the remains of Rife's laboratory to investigate what was the situation, was this something or not, and also in the quest for glom, because this guy had a lot of RF parts, and the glom was the most important part in my mind, but I wanted to see what was going on. And then basically I saw the present apparatus that Rife had made. I didn't really know a lot about him, and all this other stuff that Aaron's been talking about hadn't really been considered yet. So this was still kind of an unknown thing. So there was a particular beam tube, and I kind of had a flashback when I held that tube in my hand of the time that in Philo Farnsworth's house that I held his father's multipactor tube. And this beam tube didn't resemble in any way the ones that have been popularized, which I think are really erroneous. And when I went through the recent compendium on Rife's work, it looks like there was a bit of effort to take this monopolar tube out of there. But the thing is, I know it exists. I held it in my hand. I saw the Tesla resonator that drove it, and I saw the 100-watt transmitter using a pair of 807s that powered this thing. So basically, it was a hot cathode device. At present, Griffin's is a cold cathode device, but it's kind of the same tube. So there's going to be later versions. There's going to be the 3A21, which will be the hot cathode, and then the either a 1A22 or a 3A22, which will have a specific gas at a specific pressure. So in a certain sense, this tube kind of independent of Rife, because we're taking this from another standpoint, but it's totally parallel. So that would be that's another use for the tubes that Griffin's making. And what's also interesting is John Trump switched from the 2-terminal to the 1-terminal X-ray, which would make sense because he was given complete security clearance to access all of Tesla's files. And then lo and behold, he comes up with this electrostatic motor, which is now a major project here. And his X-ray devices were monopolar rather than bipolar. And Griffin's found with his monopolar tubes that regardless of the intensity of radiation, it has no harmful biological effects. And Tesla shows that the desired effects of producing visual images of various objects was increased by significant factors. So that's kind of what's going on with that, and that's how Rife ties in.
Right, and that will be the topic of my presentation for this year, and as well as some physical demonstrational apparatuses that will not just be confined to my presentation, but will allow you to see the projection of the rays emanating forth from the tube, and really the actual picture or the so-called X-ray image of it could be seen live. But keep in mind that these are not conventional X-rays, as Eric had alluded to. It's something rather unique, something peculiar that no one has really studied or has stumbled upon over the last 100 years. So this will be an interesting presentation.
So I'll show the, let's see, I'm gonna do a screen share here of the website. Got a second here. So if you go to emediapress.com and if you scroll down past the conference banner, there's an RPX banner, and if you click on that, it'll bring you here, or you can go to emediapress.com/RPX3. These are the units that I've been manufacturing for a while now. It's all self-contained, its own battery signal generator, sweeping signal generator inside as the internal signal generator to mix with the carrier, or you can flick a switch that says external, then you can connect your own external signal generator to it if you want to get more fancy or more specific that this unit doesn't do. You can use this as a universal harmonic generator. A lot of people are fixated on the specific frequencies like 432, 528, whatever. But whatever frequency you want to focus on, if you use this and an external signal generator, you can just scroll. Well, I would recommend, if you want to know about the right frequency generating method, watch all the videos on the website. This video, I even give you a walkthrough doing the basic math. I mean, with basic math, you can calculate, well, what is the target frequency you want? What's your carrier frequency? And that will tell you what audio frequency you need to inject in order to create sidebands that are even and odd harmonic multiples of your target frequency. So you're creating all these sidebands that correspond to that particular desired frequency. So for example, if you want to use this to make harmonics of like 432 or 528 or whatever, you can scroll to the bottom of this, and Simon Davies with TeslaScientific.com made this little calculator here. So if the carrier is 3.1 megacycle, which we do use on the RPX, and your desired frequency is say 432, you just hit the tab button, and basically what it shows is that your signal generator frequency is 32. And if you do the math, and if you take an audio signal generator and you set it to 32 hertz sine wave, and you have that output into this sideband generator, the RPX unit with a 3.1 megacycle carrier, that you will create these sidebands that are exact multiples of 432, because the power always seems to be in the harmonics and not the specific frequency itself. And that's kind of related to that Tesla earthquake machine somebody else was asking about. But anyway, we just put together a batch of 30 units. Half of them are already gone, and I think I have about maybe 10, 11 RPXs. So if anybody orders, they can ship within 24 hours. There's 10 or 11 units. We might not be able to get any more together until after the conference. So that's all I can say about Rife right now, but I'm looking forward to doing some experiments with the tubes Griffin is making. I can't go into details on it, but there is a variant of this RPX that will be higher power to light up a tube. It's a different machine, and we're going to see if there's a way to adapt it to be able to use Griffin's tubes. And if not, maybe Griffin can make a custom one specific for that application. And then for the first time ever, you're going to have the, single electrode or
Right.
monopolar Rife tube setup, which has never been seen or done anything with since
even known
probably
about.
Rife. Yeah, and what Eric is describing about Crane having all this stuff, if that was maybe possibly like an ultimate or a next step that Rife was working on that nobody is talking about, knowing what I know about John Crane through John Bedini, who figured out pretty quick that John Crane hadn't the slightest clue as to what was going on.
We called him a gold panner.
John Crane is the one who started the signal generator scam, and most of the so-called Rife machines out there are completely phony because they're nothing more than glorified signal generators where you're just supposed to punch in the signal, the specific frequency, and suddenly that's a Rife frequency generator. Well, it's not. If it's not making sidebands the way I explained and what you'll see in the videos on that web page, if it's not creating the sidebands that correspond to those Rife frequencies, then it's not a Rife machine and it's completely fake. So there is no way John Crane would have developed and done any of that stuff based on what John Bedini told me too, spending a lot of time with him. And John Crane just had glommed onto that stuff from Rife himself. So Rife or Hoyland or somebody came up with that. And there's not really hardly any information that you can even find about what Eric is describing. So this is a whole new direction we could possibly go with all that nobody has any idea about right now. So that's that.
So I think it's been plenty.
Okay, well, if there's no final questions, we've got about 3 minutes until it's 2 o'clock and we got 2 hours. Otherwise, we'll probably see you on, I think it's the 15th or so, whatever the Friday is following the conference. Conference is the 5th through the 9th. So whatever the following Saturday is, while Adrian is still here, we'll do some more updates because right after the conference, we'll do more with the RF stuff and also the Colorado Springs coil setup that we had at the 2019 conference in Hayden, Idaho, which was a 20-to-1 scale model replica of the Colorado Springs magnifying transmitter. That was Eric's presentation, and Eric and Adrian are going to be working on doing some enhancements, and we're going to see if we can take that to the next level and possibly do a whole presentation on that and at least get that recorded before they leave. And so I think that's about it
Yeah,
for now.
you are you.
Okay, well, thanks for joining everybody, and we'll see you at the conference. And if you're not there, we'll see you at the next Zoom call.
Thanks, Aaron. Very good.
Okay,
Always a
thanks
pleasure.
everybody. We'll talk to you all later. Thank you.